So in the next we'll move on to the next topic, that is LCD interfacing. LCD, in the recent years, the LCD is finding its widespread using, it is replacing the LEDs. Okay, so we'll see how to interface this LCDs, liquid crystal display. Okay, 7 segment LEDs and other multi-segment LEDs, it is replacing the LCD because of the declining prices of LCDs, the ability to display numbers, characters and graphics, and this is in contrast to LEDs which are limited to numbers and few characters. Here we can use the graphics also in LCD, and in incorporation of a refreshing controller into the LCD, thereby relieving the CPU of the task of refreshing the LCD. In contrast, the LED must be refreshed by the CPU to keep displaying the data. Okay, it is the comparison between LCD and LED here. Ease of programming for characters and graphics. So the next in LCD they'll be showing what are the pins, what are the how the pins are used, what are its uses and all. While VCC and VSS provide +5 volts and ground. Okay, V is used for controlling the contrast. Okay, to control the brightness, this V will be used. So pin descriptions of LCD is given here. VSS is for ground, VCC for +5 supply. This is power supply to control contrast, and RS is important. When RS is 0, it will be selected as command register to give commands. When an RS is 1, it will be selected as data register. This is important. Next we have read write. If it is 0, it will be used for writing, and if it is 1, it is used for reading. Enable we have, and next all from DB0 to DB7, all are the 8-bit data bus. It can be used for input and output, and we have an enable also. So these are the pin descriptions of LCD. There are some different positions of pins for different LCDs are shown. Here important RS is the register select. There are two very important registers inside the LCD. The RS pin is used for their selection. When RS is 0, it is used to select the command code register. Okay, command code register is selected, and that what it will do, it will allowing the user to send commands such as clear, display, okay, cursor at home, etc. And if RS is one more register is data register. So two important registers are command code register and data register. Depending upon this register select, it will be selected, allowing the here when the RS is 1, that is when register select is 1, then data register is selected, allowing the user to send data to be displayed on the LCD. What data you should display on the LCD, that will be decided by this data register. And what command should be given, if you want to clear the display, if you want to see where the cursor is, that all will be decided by the code register. Next we have read write, which allows the user to write the information to the LCD and read the information. Next we have enable pin, that is used by the LCD to latch information presented in its data pins. When data is applied to data pins, a high to low pulse must be applied to this pin in order for the LCD to latch in the data. Whatever the data, that should be latched or that should be stored. Next we have D0 to D7. These are the 8-bit data pins and that are used to send the information to LCD and to read the contents of the LCD's internal registers. So if you want to display letters, numbers, so they'll send ASCII codes for the letters from A to Z and small a, that is uppercase and lowercase, and numbers 0 to 9. Okay, there are also instruction command codes that can be sent to LCD to clear the display log. See here, that is been shown here, LCD command codes, it is important, and hexadecimal, hex code also is given. 1 stands for clear display screen, 2 for return home, 4 for decrement cursor, 6 for increment the cursor, then shift display right. Like that we have many command codes here, and 80 means to force the cursor to beginning of the first line. If it is 10, it is shift cursor position to the left. Okay, these are all the command codes that are used for displaying on the LCD, and all are in the hexa code. Next we have keyboard interfacing the keyboard to 8051. Keyboards and LCDs are the most widely used input-output devices of the 8051. And the basic understanding is required here. So at the lowest level, keyboards are organized in matrix, rows and columns. They are important. Okay, rows and columns. The CPU assesses both rows and columns through ports. Ports are used. Therefore, with two 8-bit ports, 8 cross 8 matrix of keys can be connected to microprocessor. When a key is pressed, a row and a column make a contact. Otherwise, there is no connection between the rows and the columns. So a single microcontroller consisting of processor, RAM, ROM, okay, all the memories take care of hardware and software interfacing of the keyboard. So this figure is important here. It shows a 4 cross 4 matrix connected to two ports. The rows are connected in an output port and the columns are connected to an input port. If no key has been pressed, reading the input port will yield ones for all the columns since they are connected to high VCC. If all the rows are grounded and key is pressed, one of the columns will have 0. Okay, grounding rows and reading the columns. So this is the figure. This is the port here. In port 1, they have taken D0, D1, D2, D3, and port 2, D0, D1, D2, D3. Okay, rows and columns. So this will act as switches. This is how the switches will be connected. This is the matrix keyboard connection to ports. To detect a pressed key, the microcontroller grounds all rows by providing 0 to the output latch. Then it reads the columns. If the data read from the column is D3 to D0 is 1111, no key has been pressed and the process continues. Okay. The process will be continuing for the for next rows until a key is pressed. Process continues till a key is pressed is detected. However, if one of the column bit has 0, this means that key press has occurred. If it is 1101, it is now 0 now. This means that a key in the D1 column has been pressed. Okay, when all are 11, no key has pressed, like that. After a key press is detected, the microcontroller will go through the process of identifying the key. Starting with top row, the microcontroller grounds it by providing a load to the row D0 only. Then it reads the columns. If the data read is all ones, no key is pressed or no key is activated, and the process is moved to the next row. So it grounds the next row, reads the columns and checks if anything is pressed. This process continues until the row is identified. This is the process how it will do to identify who has pressed the key. After identification of the row in which the key has been pressed, the next task is to find which column the pressed key belongs to. This should be okay, that will run. Okay, to make sure that the preceding key has been released. See, whatever the steps they have given, they have put everything in the flow chart here. To make sure that the preceding key has been released, zeros are output to all rows at once and the columns are checked repeatedly until all the columns are high. When all columns are found to be high, then the program for a short amount of time before it comes to the next stage of waiting for a key to be pressed. So to identify the key press, the microcontroller rotates the column bits one bit at a time into a carry flag and checks to see if it is low. Upon finding the 0, it pulls out the ASCII code for that key from the lookup table. So the procedure that goes for keyboard interfacing, okay, that everything is put in this flow chart, all that words they have written that I will explain here. So it will start. So we will ground all the rows. First all the rows will be grounded. Then it will read the columns. Okay. When it read the columns, it will see any keys are pressed, all keys are open, or it will see. If it is no, it will be at that point only. If it is S, okay, if it is X, it will read all the columns. It will see any key is down. Okay, if it is no, it will remain there. If it is X, it will wait for the debounce. Then again it will read all the columns. Any key down, if it is no, it will go back. Okay, this procedure will be continuing. This is one procedure. Next is if ground next row. For next is continuation. Again it will read all the columns. If key press in this row, if it is in this row, if it is no, it will go back. If it is yes, it will find which is pressed. So get the scan code from the table. So this is the flow chart which tells you about the keyboard interfacing. Here one the rows are grounded, then columns are red. Here also the rows are grounded and columns are red, and see which key is being pressed. So this is about keyboard interfacing. So the two switches are connected to pins P1 and port 0. They are also vector to interrupt location. Write a program to test which key is pressed and verify if both keys are pressed. Since two switches, depending upon this the flow chart, you can write a program. Try writing the program. So these are some important concepts of keyboard interfacing and LCD. Okay, thank you.